session for BigQuery ML. We had the info session for BigQuery ML last month, and after that, we had the data engineering lab session, and now we are going to do the lab session for BigQuery ML. In the info session, we covered a use case of logistic regression, which was basically uh, classification to predict either of the two classes for that given problem. Today, we are going to go ahead and see a few more use cases. So this is how the events have been so far. We had the cloud computing track, we had the data engineering track, we are currently on the machine learning track, and coming ahead in the next few weeks, we have the AI track. GDSC UB sessions are held every Friday from 4 p.m. to 5 p.m. You can sign up for the sessions and you'll get an invite whenever an event is scheduled. Okay, so before we go on to actually doing a hands-on with the lab session, let's do a quick recap on what machine learning actually is. We learned that machine learning, artificial intelligence, deep learning, data science, all these buzzwords, if we were to classify them using, say, a Venn diagram, this is what it would look like, where deep learning is a subset of machine learning, which is a subset of artificial intelligence, and data science coincides with all of these sets, and there are some additional methods apart from them. So what is the machine learning process? Machine learning process is where your machines learn the set of rules given your output. It tries to create a set of rules such that in the future, when the same rules are applied to a data which it has not previously seen, it will try to correctly, accurately predict an output. So this here can be broken down into different steps. You first decide what the user wants, define the objective of the problem, collect data, you divide the data into train set and test set. On the train set, you test your model using the test set, and then you predict your outcome, and you keep refining your model based on whatever evaluation metrics you have chosen. These are some of the machine learning types. There are others, but we're primarily going to talk about this for the context of this lab session. So there's supervised learning, there's unsupervised learning, there's semi-supervised learning, and reinforcement learning. Let's talk about supervised learning and unsupervised learning because that's what we are going to cover in the BigQuery ML lab sessions. So supervised learning is where you already know what the target variable is. For example, let's take an example of, okay, so it's a rainy day today. So if I want to predict whether or not it will rain today, so that's like a classification problem. There are two answers, yes and no, right? Uh, so that's a supervised learning problem. Uh, you can again classify that into two different types, which is regression and classification. So the example that I just gave is an example of classification. Regression is where you try to predict, let's say, if it will rain today, how much today. So that's a regression problem. In unsupervised learning, you do not have the target variable at hand. You do not know the target variable, but what you're trying to do here is of the data points which show similar behavior. For example, let's take in the context of the same example we have used for previous two cases. So what are the areas of Western New York where the rainfall today has been, similar. So you could cluster those regions together, and based on that, you can achieve whatever objective you have for your machine learning process. So that's unsupervised learning. Okay, uh, that was supervised and unsupervised in brief. Going forward, these are some of the use cases that that we can talk about in terms of machine learning problems. For example, if you want to detect whether for a bank transaction, that particular transaction, was it a fraudulent transaction or not. So that's fraud detection use case. You could apply different classification methods for it, or you could cluster together the fraudulent transactions and find out what type of similar behavior they show. And that is how bank transactions are detected, whether they're fraudulent or not. Some other use cases are listed over here. We've already covered some of them in the last session, so I'll go forward. So what actually is BigQuery? BigQuery is a fully managed enterprise data warehouse where you can do all your machine learning tasks in one place. It makes use of simple SQL queries, so you don't need to have knowledge of any programming language to get started. While that is the case, if you want, if you have some advanced use case where you want to actually integrate any of your applications with BigQuery, BigQuery provides different APIs to interact with the applications. Um, BigQuery is designed to ingest, store, analyze, and visualize data based on the Dremel system. So the Dremel system was, again, a very I think I lost. Hello, am I audible? I think I lost connection. Okay, I am back. Sorry about that. Uh, so I was talking about Google BigQuery, where so it's based on the Dremel system. Um, Dremel is a scalable query system designed by Google, which helps to combine multi-level trees and helps to deal with columnar data. It is capable of running aggregation queries up to a petabyte of data. And so the base of the Google BigQuery is based on the Dremel system. Uh, Google BigQuery is highly scalable, and it's possible to scale your data based on need. uh, to divide the BigQuery pipeline, we're going to talk about it in mainly three different types, three different stages. That is storage, ingestion, and querying. So the data is stored in a structured table, and you can use standard SQL for easy querying and any data analysis that you want to do. Um so that is what makes it highly scalable. It is also distributed. The next is the ingestion step of the pipeline, where you can either upload data using batch, or you can upload it using storage buckets, which are on Google Cloud or any other cloud, or you can simply upload data on the UI. It's also possible to upload data uh, that is streaming in from some other application using data flow, parts of which you might have studied in the last few lab sessions of data engineering. It's also possible to, if your data sets are coming in from different types of sources, like let's say it's a combination of JSON data, CSV data, or simply Excel files. You can merge and combine all of that using different suite of Google products like Cloud Data Fusion, and you can ingest it in one place in BigQuery. The next and the last step of this is simple querying, which uses standard SQL queries. You can do joins, you can do nested joins, you can do aggregation, you can do multi-statement queries. Uh, all of those things are possible in the querying stage. All right. So going on to the problem statement at hand today. So we are going to use a sample NYC taxi cab fare dataset for BigQuery, and we're going to create a model that predicts the taxi cab fare based on a number of different factors that we have in the dataset. To do that, to do the forecasting of the cab fare, we are going to create a linear regression model in BigQuery. Okay, by the way, if in this step of BigQuery, if you want to skip the storage and ingestion step, you can simply use, and if you're just learning right now, you can simply use the publicly available datasets on BigQuery, which are all on Google Cloud available for free, and you can directly go to the querying stage. Before we move to the lab session, these are a few links on how to stay connected with GDSC UB. I will be switching to the lab session now. I hope everyone here present has Google Cloud credits, which are continuing from the last lab sessions. And if any one of you require new tokens for Google Cloud credits, please let us know. Fill in the form for Google Cloud credits, which is the form is available on our Slack channel. You can fill it, and we'll provide you with new tokens. Okay, so here we are going to predict the taxi fare by creating a forecasting model. This is like a 1 hour session, and it requires one credit. I'm going to start the session now. Okay, some basic capture. So whatever credits available you have, they'll be displayed over here. So I have clicked launch with credit. And once you have launched it, you'll get this option where you can open Google Console. You have a username, password, and the project ID. Make sure to open the Google Cloud Console in an incognito window. That way it won't interact with your private Google ID, and it'll only use the cloud credits that the club has provided. So I'm going to copy and paste the password as well. Okay, so in this lab session, we're going to use BigQuery to find different public data sets. We're going to explore the public taxi cab data set, and we're going to create a training set. We're going to create an evaluation set, and we're also going to see how that can be used for batch prediction. And after that, we'll create a forecasting model. We'll try to tune the forecasting model, and finally, we'll get a performance, whatever performance of the model that we get with the fine-tuned model, we're going to use that to evaluate. All right. So once you are on this page, you need to go to BigQuery. I'm going to click OK. All right. So the first step is we need to first create a data set, but we don't need to actually upload anything. The NYC taxi cab fare dataset is already available on Google Cloud. So you can directly access it using the query. So there's an entire query posted over here on the tutorial page. I am going to copy that here, and we're going to do some analysis on that. So it says select timestamp, pickup date time, comma month as month, count the number of trips from. This is the name of the data set of the publicly available version of uh, this thing. Group by one, order by one, which means we're going to group by this particular field. So this is what it shows. You can see this data set is from 2015, and for all the 12 months, these are the number of trips. That's quite a lot of trips. You can check different information regarding each query that we're going to run in the job information. And it's also possible to get this data in a JSON format. Next, what we're going to check is what was the average speed of yellow taxi trips in 2015. So I have a query for that. I'm going to create a new editor space, and I'll paste it here. So again, what we are checking here is the average speed of the taxi trips. And this is the important part where we are doing, where we are filtering the data based on certain conditions. We want the trip to be the trip distance to be more than 0. And we're going to split the fare amount between 2 and 10. There's a drop off time, there's a pickup time. So we don't want the drop off time to be less than the pickup time. Uh, this is where we are calculating the average of the trip distance upon time. I'm going to run this query. Okay, so we have a result. So in a 24-hour system, uh, these are the different speeds at different times of the day. What we can see here is at around 5 a.m., the average speed of the taxi cabs are the highest, since so logically one would assume that there's very little traffic at an odd hour of 5 a.m. So naturally the average speed of cabs is more, whereas compared to, let's say, around 11 a.m., it's 11.3. So one can assume that there's a lot of traffic around the working hours. Okay, next, we need to identify an objective. Uh, so here our objective is we are trying to predict the price of the cab ride. We have this in our tutorial page. So first we are going to try to select different features from the dataset. Uh, Here are a few links where you can actually check what are the different list of fields. We're not going to use all of them. The ones which we are going to use, we have listed them over here. So what are the different tolls that the cabs have to face? What are the actual fares, which may depend on the distance? Uh, to get the actual distance, we have the pickup address and the drop-off address. What is the hour of the day? It's possible there's a surge in pricing during peak hours, and the pricing is not so high during not non-working hours. What are the number of passengers? Okay, so again, I am going to paste this query in a new editor. So as you can see here, we have let's divide the entire query into different parts. Here we are creating two different sets, one as train and second part as eval. So we are going to train our data set using the train set and then evaluate it using the eval set. We are going to name the different days of the week. The total fare is going to be the tolls amount plus fare amount. And since days of the week are ordinal features, we're going to write this part of the query. And then the other features that we talked about, pickup location, drop off location, passenger count. Again, we want the trip distance to be greater than 0, fare amount greater than 0. I am going to run this now. So the where clause uh, is the part where it actually filters the data. Okay, we have a result. So total fare, this one is the column we are interested in. This is what we will be predicting. And you can see that at some places the price is high, and at some places it's very low, right? It's possible that our data set has outliers. We're going to handle the outliers later. To go on to the next step, we will first create a data set. The steps to create a data set are you click on this section of the Explorer, click on Create Dataset. This is the project ID for that dataset. We need to name it. Let's name it Taxi. Select the different data locations. And the good thing about BigQuery is it also provides options for data centers which have low carbon emissions. For now, we're just going to select the default one. Okay, so you can see here the data set is created. This is information about the data set. Now, next I'll create a new editor and we're going to type in the query to create our forecasting model. For using forecasting, we are going to use linear regression. BigQuery supports a lot of different models for supervised and unsupervised learning. Some of them are logistic regression, which we saw in the last lab session. There's k-means clustering, there's matrix factorization, there's gradient boosted tree-based methods. There's also deep neural network methods, autoencoder methods. For now, let's go with the linear regression for forecasting. So there's a question here which asks which model type should you choose for predicting taxi cab fare, which is a numeric value. So it's linear regression. That's the correct answer. Next, I have copied the query. I'm going to paste it over here. Here we have specified, I'm going to run this and then we'll talk about the query. It takes a while to train the model. So it's the model type is linear regression. You can get the definition of all of these parameters in the documentation. Labels, if you want to explicitly have to define the labels part, with this is the dependent variable, which is what we are going to predict total fare. You can define it as labels unless you want to directly use the existing column, which is already named labels. Again, we've divided into two parts. For one as train, two as eval. We have created a field day names, and we've selected the features, same as the previous query. The query is still running. Takes about 3 to 4 minutes. Okay, the query is completed. So these are the details of the model. You can see it's linear regression. The performance metric that we are going to use for linear regression is mean squared loss, which is basically, so again, going back to our old example, or let's just take the taxi cab fare example. Uh, the actual data point has a value which says that the taxi cab fare is, let's say, $20, but what your model has predicted is $25. So in this case, there's a residual, there's certain error in your prediction. That's $5, right? $25 minus $20, that's $5. So that is the residual for your case. And uh, this error is something that we are trying to avoid. We are trying to minimize, right? We want our model to have an error which is as low as possible. There are different performance metrics. One of them is mean squared loss, which we are using for this case. Uh, some other training parameters are listed over here. So the training data loss, evaluation data loss, and what is the duration it took to train this particular model. So we already have a model now. Let's try to evaluate it. Uh, how does this model perform? I will now create a new editor. So one of the key things to note here is when we are evaluating, since we are simply using SQL queries and we need BigQuery to differentiate when we are training and when we are evaluating, This is the keyword that we use, ml.evaluate. Whereas if you see here, it's different, right? It's create or replace model. So the RMSE, that is root mean square error, that we got in this case is 9.47, which is on the higher side. We want it as close to 0 as possible. So what we could do here is could try to refine the data set that we are using, or we could select a few different features which we were not previously selected, or we can try to tune the hyperparameters of the model. So our next task would be uh, before we go on to tuning the model, uh, we had divided our data set into the train set and the test set, and on the test set we evaluated the model. Let's actually use this to predict uh, using our model. So I'm going to paste the SQL code for predicting. This is the syntax for predict statement, m1.predict. This part of the entire query is the same. What's changing here is this part, and I'm going to run this. So these two columns are what we are interested in. This is the total fare, which is the actual ground truth, and this is what our model has predicted. So the an RMSE with an RMSE of 9.47, I'd say this is not a very good model as of now. Uh, we need to improve this model. So to improve this model, let's do a little bit of feature engineering, where I'm just going to create a new editor. Okay. Here first, let's try to understand our data set. To understand that our data set, what's the distribution of the fares look like. We're going to find the total count. We're going to find the minimum, maximum, and average, along with the standard deviation of the actual fare amount. And remember, the total fare goes fare amount is the sum of fare amount plus the toll amount. So this is like just one of the factors of the fare amount, total fare amount. So here we have these many number of fares. The lowest fare is of this value. The highest fare is of this value. Average fare is this, 11 point something. And this is the standard deviation. Something to note here is these two values seem like very odd numbers. These don't actually fit into the distribution. Maybe they're anomalies. We need to figure them out. So what we are going to do is we're going to filter our data to exclude these anomalies so that they don't affect our model. So I will create a new editor over here again. The statement is going to filter my data set such that the trip distance is actually greater than 0 and the fare amount is between 6 and 200, which seems like a logical range to have for uh, cab fare. Okay, there's some syntax error. Okay, so we have filtered from a higher number to a lower number of fares. We now only have these many number of fares. The lowest fare is 6, the highest fare is 200, average fare is this value. And we have also limited the distance. Uh, I'm going to type another part of the query. Limit the distance. This is what I'm going to do, where I am going to limit it using the latitude and the longitude of pickup, latitude and longitude of the drop off. Filtering it further is going to improve the quality of my data set even more. The standard deviation has also reduced. Okay, seems fair enough now that our data set does not have outliers. It's possible that the model performance will improve. Let's retrain this model. I'm going to run. This will take about 2 to 3 minutes. So what we are doing to calculate the actual distance from the pickup and drop off is we are calculating the Euclidean distance, which is simply the L2 norm between these 2 points. The query is still running. Okay, model is ready. Here our new model can be seen, taxi fare model 2. So you can see the metrics have improved. What we have been checking is the root mean squared error, which is now 0.8, right? Let's try to evaluate this new model that we've created. And this is ml.evaluate, which is the only thing different where previously we had create or replace. We have ml.evaluate over here. So we're going to use the square root of the mean squared error. I'm going to name it as RMSE. Rest of the things are same. So from a previous value of 9.47, it's now reduced to 5.12. So that's an improvement, right? And this model seems good enough compared to the version 1. So yeah, I think we can say that we have successfully trained a model to predict the cab fares given these factors. So if we get some new data point, we can approximately predict using this model. Going back to our tutorial, here's a question. Below are multiple choice questions to reinforce your understanding of the SLAP's concepts. A lower RMSE is usually better. You want your models to perform better, and that's possible when you have a lower RMSE. Some other data sets to explore. That concludes this particular use case. Some other data sets to explore, you can find them, which are publicly available. Uh, you can explore them. You can try out different models other than linear regression. And that brings us to the close of this lab session. Uh, there are a few more quests in this which you can do. So we covered this getting started lab session in the first info session. Today we have covered the predict taxi fare with BigQuery ML forecasting model. There's about 5 quests in total. You can complete all of them, and you can uh, get a completion badge. And yeah, I think that's everything for the BigQuery track. Are there any questions? I'll take a minute to take any questions. Okay. In the upcoming sessions, we're going to do more complex unsupervised methods using Vertex AI. Uh, Stay tuned for any updates on the upcoming events. And I don't think there are any questions, so I'll stop sharing now. Thank you everyone for joining today's session. Hope you have a great weekend.